Hi there, I'm Chris Saxon, the Sequel Wizard. So far in the Red Candy series, we've been looking at ways we can find all the red sweets out of my party bags here. And I've been doing so because I want to assume that not only do I want to know what colour each candy is, so whether it's red or not, but I want to know other attributes about them, so the weight, the dimensions, and so on. Or of course, maybe I just want to eat them. In this episode, I'm going to ask a different question. All I want to do is just count how many sweets are red. Just want the total number. This is so that when my daughter comes to me and demands to have some red ones, I know how many to give her so I can ration them out over the next couple of weeks. Let's compare using the full table scan to using the index to answer this question. First up, full table scan. Still got to go pick up every single bag, look at every single sweet and see which colour it is. If it's red, then I'm incrementing a counter. If it's not, then I don't. So I'll pick up each sweet, put it back, check if it's red or not, and do this for every single bag and every single sweet. Alternatively, I can go to my document here, my index. I can navigate to the first red entry, and then to just count how many are red, all I need to do is just see how many rows in the document are red. So this gives us the total number. Key thing to note here is that I can answer my question just by using my document. I don't need to visit the table at all. I don't need to pick up the sweets themselves and check the colour. The index holds all the information I need. How does this affect performance? Let's take a look. There's two key things to notice. First up, with my full table scan, I'm still having to look at every single row in my table. Still need to pick up every candy and check which colour it is. However, with my document, it's an ordered data structure and I can restrict my search to just those entries that match my search criteria. So in this case, which are red. So this means I'm processing a subset of the data when I'm using my index typically. Got 8 different colours of sweets, therefore I only need to look at 1/8 of the entries in the index here. Second thing to notice is that typically indexes are smaller data structures than the tables they're created on. With our candies here, not only do we store what colour they are, but we also store various other attributes about them. Their weight, their dimensions, what flavour they are they chocolate or peanut, are there any manufacturing defects, and so on. So there's just more data stored in the table compared to the index, which just stores 2 items, the value of the colour and the location of the sweet. This means that because the index is smaller, even if we have to read all the data out of it, it's just going to be quicker than reading all the data out of the table, because there's less to do. If all the information you need to answer your query is stored within an index, then Oracle doesn't need to access the table at all. It's able to do what's called an index-only scan. This is typically much more efficient than access methods which involve using the table because there's much less data to process. To enable an index-only scan, all the columns listed in your query must also be stored in a corresponding index. For example, in this situation here, let's say we don't want to find just how many sweets are red, but we want to find the total weight of the red candy, then our document here isn't good enough. We can use this to find how many are red, but we still actually got to go to the table to get the candies to find how heavy they are. To enable an index-only scan in this case, we need a new index that has the weight and the colour. This is something we'll take a more detailed look at in the next episode. I'm Chris Saxon, thanks for watching. Thanks for watching. I'm Chris Saxon, the Sequel Wizard. Subscribe to my YouTube channel to get future updates on more SQL magic. I'll see you next time.